We are starting the mechanics paper of this mock exam of Deacon House 2025, where the total marks are given there equal to 50 and the total time given there is 1 hour 15 minutes. We are starting question number 1 now. A ring of is threaded on a fixed horizontal bar. The ring is attached to the one end of the light inextensible string, which is used to pull the ring along the bar at a constant speed of zero point 0.5 meters per second. The string makes an angle of 24 degree with the bar and the tension in the string is 6 Newton. Find the work done by the tension in the period of 8 seconds. So, question number 1, there's a horizontal bar, there's a ring attached to that bar there with the strings, with the tension T. It is having magnitude 6 Newton. This will make an angle of 24 degree. And you are going to find out the work done by the tension where speed of that particle is equal to 8 meter per second and the time there is equal to zero point 0.5 seconds. And this speed is constant. So you can leave this as V there. Now we know that if we resolve this into two components, this is T sine of 24 and this will be T cos of 24. This is the normal reaction R to that. This is the weight of that object and this is the frictional force acting on that object there. But they have just asked to find the work done by the tension there. So we know that the work done by the tension is equal to driving force into the distance, which is S there. But the driving force is basically equal to P cos of 24 because only the horizontal force is acting on that particle, which is responsible for the motion of that ring there. P is 6 cos of 24. So that is Newton there, 6 cos 24 there. Now the work done due to this tension will be equal to driving force into the distance. So driving force is basically equal to 6 cos of 24 and the distance is basically equal to speed into time. Speed there is equal to 8 into time there is 0.5 seconds. So the total work done will be in joules there. So that value is equal to so that thing is equal to 21.9 joules. That is the work done due to the tension of that string there. Now we are going to start the second question. A car of mass 1500 kg is rowing a trailer of mass mkg along a straight horizontal road. The trailers are connected by a tow bar which is horizontal, light and rigid. There is a resistance force of F Newton on the car and a resistance force of 200 Newton on the trailer. The driving force of the car engine is 3200 Newton. The acceleration of the car is 1.25 meters per second square, and the tension in the tow bar is 300 Newton. Find the value of mass m and the value of F there. Now, in this question, car is connected by the trailer with the tension key there, which is being balanced. The driving force for this is 3,200 Newton, and the resistive force for this car is F1, which is F Newton, and for resistive force for this trailer there is F2, that is 200 Newton. Acceleration is 1.25. But always the conceptual part of this part is that you are just going to use first the trailer, where the driving force is the tension, and the resistive force to that particle is F2, which is equal to 200 Newton. There is a normal reaction R to this object, which is being balanced by the weight of this trailer there. So we know that R1 is balanced by weight of that trailer there. Now we have this equation of motion here, that the driving force minus resistive force is equal to net force. So driving force there is tension minus the resistive force is there. So tension here minus the resistive force is there F2. That is equal to mass of the trailer into the acceleration A there. But we know that tension there is 300 Newton minus frictional force there is 200 Newton, which is equal to mass of that trailer is M into acceleration there is 1.25. So 100 is equal to M into 1.25. So mass will be equal to 80. So this is the value of M, which is equal to 80 there. Now they are considering the find the frictional force F there. So now we will combine these two particles like this. Then this is the car, this one is the trailer. So they both will combine together and they are being dragged with this driving force there is equal to 2200 Newton. On this car, there is frictional force F, and on this trailer, the frictional force there is 200. Because tension is being balanced, so there is no effect of the tension on this part there. Now, the driving force is 32, and I just read this driving force minus resistive force is equal to mA. Driving force is basically this 3200 Newton minus, there are two resistance forces acting on that. One is the force F and one is the force 200 Newton, which is equal to mass of both these. So car and the trailer, so their mass will become equivalent to 1500 plus 10 into acceleration there is 1.25. But we have already calculated the value of m there, which is equal to 80. So this will become 3200 minus f minus 200 is equal to 1500 plus 80 into 1.25. Our f will be equal to 3200 minus 200 minus 1500 plus 80. 1580 into 1.25. So F will be equal to 1025. So F value is equal to 1025. So these are the two values which we have to calculate, the values of M and the value of F there. Now we'll start the third question. Question number 3 now. A particle is being projected vertically upward with a speed of u meters per second from a point on the horizontal ground. After 2 seconds, the height of the particle above the ground is 24 meters. Show that u is equal to 22. Question number 3. A particle is being projected from this point on the ground there upward with the speed u meters per second. When it is at a height of 24 meters above the ground, the time taken there is 2 seconds. You have to show that u is equal to 22. This thing you have to show. We know that when the particle is moving upward, we can use this equation of motion S is equal to ut minus half gt square. So because it is moving upward, so that's why we are using this minus sign here. Now S is there the height which is 24 meter there is equal to u we don't know. Time is 2 seconds minus half g is 10 into t is 2 square. So this will become 24 is equal to 2u minus 4 over 2 into 10 20. So this 2u is equal to 24 plus 20, that is equal to 44, or u is equal to 22 meters per second. But it's only they have asked u, so you are going to use already the meters per second, so u will be only 22 there. This is the first part of this question. Now the second part. The particle, the height of the particle above the ground is more than h meter for a period of 3.6 seconds. Find the height h there. Now, since this particle is at a height h meter above the ground, so let's say this is the ground, and here from this point, particle is being projected upward with the speed we have already calculated now u is equal to 22 meters per second, and it is more than this comes to the ground at this level, but it is you are going to calculate this height above the ground, and from this point A to B, this total time in between A to B there is 3.6 seconds there. So you are going to calculate this value of height h there. Since we know that if a particle is being projected upward, then at the highest point, its velocity will be equal to zero, where u is equal to 22 meters per second. And let's say we get this height, capital H, which is the maximum height there. Because it is moving upward, so we can use the same equation of motion here. V is equal to u minus gt. V is 0, u is 22, minus 10 into time t there. So time t will be equal to 22 over 10, and that is equal to 2.2 seconds there. So that means you can calculate the height from this ground level to the highest point there. And here the total time there is 2.2 seconds. So the same time taken by this from the highest point to the ground will be 2.2 seconds. But it is always we are going to find out the height h, which is above 3.6 seconds from this ground. So you have to calculate from A to B, the total time there is 3.6. So we know that if the time taken from A to B is 3.6 seconds, then this is the total time there is 2.2 seconds from this ground level to this highest level there. So let's say this is the height we are going to get from this object there. So the same time will be taken from the highest point to the lowest point there. So that means the total time here given there is 3.6 seconds. So it means from this highest point to this point, or from this K point to this highest point is the same time there. So we can use this thing as t plus t, that is equal to 3.6. So 2t is equal to 3.6. So t is equal to 1.6 seconds. That is from this time when it's come from the highest point to this B, or from this lowest point to this highest point there. So the time there is 1.8 seconds. And now we are going to calculate the height of this object there. But when it is going to make a turn there, this final velocity will become the initial velocity, and that will become equal to 0 there. And we can use this equation of motion there. S is equal to ut plus half gt square, because now it is coming downward from that highest point to this point B there. So u is 0 there, t is unknown, half, g is 10 there, and time there is 1.8 seconds square there. So that will become equal to 5 into 1.8 square, and this will become equivalent to 16.2. This is the height h1. From this point to this, let's say, this is your height h1. Now you will calculate this total height of that object there, which is s is equal to ut, 2h is equal to u square minus v square. So h is equal to 2gs is equal to v square minus u square. 2, g is 10, s is capital height h, that thing is equal to v square is 0 square minus u square is 22. So H will be equal to 24.2. So the required height H is H minus H1. So that thing is equal to 24.2 minus H1 there is equal to 16.2, and that thing will be equal to 8 meters. So this is the height H of that particle when it is always 3.6 meters above the ground. Now we'll start question number 4. Another an athlete of mass 84 kg is running along a road. Initially, the road is horizontal and he runs at a constant speed of 3 meters per second. The athlete produces a constant power of 60 watt. Find the resisting force which acts on the athlete. We know that power is basically equal to driving force into velocity. Power given there is 60. Driving force we don't know. We are going to calculate it. Its velocity is constant at 3 meters per second. So driving force will become equal to 60 over 3, and that is equal to 20 Newton. The second part of this, the athlete then runs up a 150-meter section of a road which is inclined at 8 degrees to the horizontal. The speed of the athlete at the start of this section of the road is 3 meters per second, and now he produces a constant driving force of 24 Newton. The total resistance for this force which is act on the athlete along this section of the road has a constant magnitude of 13 Newton. Use an energy method to find out the speed of this athletes of this particle at the end of this 150-meter above section of this road there. Because we are going to use this energy method here. So first of all, let's say the height attained by that particle is h there. Now, potential energy is basically equal to mgh, where h over 150 perpendicular over hypotenuse is equal to sine of zero point 0.8. So height is equal to 150 into sine of zero point 0.8, and that value is equal to 2.09. Now, kinetic energy, which is equal to kinetic energy at the final minus kinetic energy at the initial. So let's say it is going to reach at this point where this is R, this is the driving force, this one is mg cos of point 0.8, and this is mg sine of point 0.8. So kinetic energy in the initial is half, mass of that particle is 84, into speed there is v square, we have to calculate, minus half 84 into initial speed is 3 square. So this will become 42 v square minus 42 into 9. This is the kinetic energy of that particle which is being used there. Now, you have to use this work energy principle. We know that work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system, because it is gaining the potential energy, so it should be equal to mgh. But there is a resistive force of 30 Newton that is also acting on that object there. So work done by the driving force, that is the driving force into distance. But the driving force there is equal to 24. So this will become 24 into 150 minus the frictional force, resistive force there is 13 into 150, which should be equivalent to change in kinetic energy, that is 42 v square minus 42 into 9. This is kinetic energy plus potential energy is m is 84, g is 10 into the height we have calculated it equal to 2.09. So this is the work energy principle we are going to use in this part there. So from this, all calculations are given to you. So from this, we can calculate that the V value is equal to. So V is equal to 2.53 meters per second. So this is question number 4. Now we start question number 5. Now question number 5. Particles P and Q move on a line of the greater slope of smooth inclined plane. P is released from rest at a point O on the line 2 seconds later through the point A with a speed of 3.5 meters per second. Find the acceleration of P and the angle of inclination of this plane there. Particle P is at O where it is released, so U is equal to 0, and after 2 seconds it is going to reach at the point A with a speed of 3.5 meters per second. You are going to find out the acceleration A on this. We know that when the particle is at this position, this is the normal reaction part of that. This is mass of P into G into sine of theta there. And this is the frictional force there, which is equal to 0. So we are going to find out the angle theta also for this angle of inclination there. We know from this famous equation, driving force minus resistive force is equal to net force. For this particle P, driving force is 0 minus resistive force is basically equal to 0 plus mg sine theta, because it is coming downward to that portion there. And that thing, so driving force is basically this mg sine theta, because this is the force which is responsible for its motion. Resistive force is equal to 0. That is equal to m of A. M and n cancel. So A is equal to g sine theta. So A is equal to g into sine theta there. So now we are going to calculate the value of this theta. But we know one thing, that its initial speed is 0, final speed is v. A we are going to first find out, and g is there equal to that A value there. So we can use this equation, v is equal to u plus at. V is there 3.5, u is 0, acceleration is A is unknown, and that is time is 2 seconds. So it will be equal to 3.5 over 2. That is equal to 1.75 meters per second square. But since this is the acceleration A there, and now you are going to calculate the value of this theta there. So A is equal to 1.75 is equal to 10 into sine theta there. Sine theta is equal to 1.75 over 10, which is 0.175. So theta is equal to sine inverse of 0.175, and that thing is equal to 10.1. 10.07, that means what, 10.1 degree. So this is the angle of inclination, and this is the value of that acceleration. Now the next part. For the second part, at the instant that P passes through the A, particle Q is released from O. After t seconds after this U is released from O, the particle P and Q are 4.9 meter apart from each other. Find the value of T. So we will first find out the value of acceleration for this particle Q. Let's say for this P part, this is the point O from which particle P is going to move. At the instant when P is going to reach at this point A, then the particle Q is going to be released and it is moving like this. After t seconds, they are going to have a distance of between them as 4.9 meters per second. So first we will calculate the distance by P there. In the first 2 seconds, U is 0 there. Acceleration is 1.75 into time there is 2 seconds. This is up till from O to A for the particle P there. Then when it is released from this point A, it is now going to move with the same acceleration and it is going to reach at the point further. So its initial speed is this. We will calculate the speed at this point after it is reaching at A. V is equal to U plus AT. So V is equal to U is 0 there. A is 1.75 into time is 2 there. So this will become 3.5 meters per second. So this is basically the initial speed of that particle from this point A there. So it will become by using ut plus half at square 3.5 t plus half, acceleration is 1.75 into time t square. Because after t time, they are going to use the distance between these two, which is given there equal to 4.9 meter there. So this is the equation of SP there. So SQ, for this SQ, we know that again we can use the same driving force minus resistive force equal to MA. The driving force for this particle is mg sin theta minus 0 is equal to MA. So acceleration is the same there, which is equal to 1.75 for this particle Q there. So U is 0 there because particle Q is being stored at this point. So U is 0. So 0 plus half A is there 1.75 into time when they are going to have this distance after T, we are going to measure. Now the distance between SP minus SQ is equal to 4.9 meters. So SP is 1.5 into 3.5 plus 3.5 t plus half into 1.75 t square minus the distance of this, that is half 1.75 into t square, that should be equal to 4.9 there. So this and this, they are going to cancel out each other. So it should be left there 3.5 plus 3.5 t is equal to 4.9 or 3.5 t is equal to 4.9 minus 3.5, which is equal to 1.4, or t value is equal to 1.4 over 3.5, which is equal to 0.4. So after 0.4 seconds, we are going to have a distance between these two particles as equal to 4.9. So we are going to start the next question, 6. Two particles A and B of masses zero point 0.4 kg and zero point 0.2 kg respectively are moving along a straight road greater slope of a smooth plane. The plane is inclined at 30 degrees to the horizontal and A is higher up the plane B. When the two particles collide, the speed of this particle A and B are 3 meters per second and 2 meters per second respectively. In the collision between the two particles, the speed of A is reduced to 2.5 meters per second. Find the speed of B immediately after the collision. We are using the law of conservation of momentum. Momentum before collision is equal to momentum after collision. So it will become mass of A into U of A plus mass of B into U of B is equal to mass of A into velocity of A plus mass of B into velocity of B there. Mass of A is there 0.4 and speed there is 3 plus mass of B is there 0.2, the speed there is 2 is equal to mass of A there is 0.4, velocity there is 2.5 plus mass of B there is 0.2 into velocity there is just equal to V of B we are going to calculate. So this will become 1.2 plus 0.4 is equal to 1 plus 0.2 velocity of B. So that will become velocity of B or velocity of B is equal to 3 meters per second. So this is the velocity of B before the collision is equal to 3 meters per second. After this collision, when B has moved 1.6 meter down the plane from this point of collision, it hits the barrier and rebounds back the same line of the greater slope. B hits the barrier zero point 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced to 90% of this. The two particles collide again 0.44 seconds after their previous collision, and now they are going to collapse on impact. Show that the speed of the particle B immediately after it hits the barrier is zero point 0.5 meters per second. Hence, find the speed of this combined particle immediately after the second collision between A and B there. Because they are moving in this way, that there is a barrier at this point A, sorry, at this point X there, you can write, which is the angle of 30 degree. There is a barrier on this point. And B particle is going to hit this, where initial speed of that particle is given to you equal to 2 meters per second. And when it hits, so we have to resolve this one into components. It should be R, it should be mg cos of 30, and this is mg sine of 30. And since this is the smooth plane, so frictional force is equal to 0. So first of all, the acceleration for this particle B will be equal to mg sine 30 minus frictional force, driving force minus resistive force is equal to ma. So frictional force is 0 there, it is equal to ma. So mg sine theta is equal to ma. So a is equal to g sine theta, g is 10 sine of 30, and that thing is equal to 10 into half, that is equal to 5 meter per second square. This is the acceleration of this particle B there. Now, for this A particle, the same equation we can use it for that A particle because it is the same sense of calculation there. So mass of A into G sine 30 is equal to mass of A into A. So same acceleration will be for A there. So we can use it that acceleration of A and acceleration of B is equal to 5 meters per second square. But now, when B is going to collide this barrier, we have to calculate that its speed is 90% reduced, and the speed of that B particle is given to you equal to, now we will calculate the respective speeds of A and B here. So first of all, the velocity of B when it hits the barrier, the speed of that particle is equal to, we can calculate it like this. We are given it start from 0. So V is equal to U plus AT. So V is equal to U is 0 there, acceleration is 5, and the time there is equal to 0.44. When V is going to hit the barrier, we know from this equation V square minus U square is equal to 2AS. But V is unknown to U, but U is there because velocity of V before that, after collision, they are given this velocity is equal to 3, so that is equal to 3 square is equal to 2. Acceleration we got it equal to 5. Into distance they have moved of this particle B, there is 1.6 meters. So V square will be equal to 3 square, that is 9 plus 2 5s are 10 into 1.6. So that is equal to 10 plus 16, that is equal to 25. V will be equal to 5 meters per second when it's going to hit the barrier there. After hitting the barrier, the speed of the particle B is reduced 90%. So 90% reduced means what? 10% of, that means what? 10% of 5. So that is equal to 1, that is 0.5 meters per second there. This is the velocity of B after hitting the barrier, well, covering a distance of what? 1.6 meters per second. Then B, from this, after hitting the barrier, it bounces back to that. So it means B portion is going to back to that portion here. So now velocity will be taken as negative because if it is positive in the rightward direction, then the negative in the opposite direction to that. Now you will calculate, and then A particle is still coming downward, and when they collide, there are masses of pulses, and now we are going to calculate their velocities after that portion there. So velocity of A, which is equivalent to velocity of A there is the speed of that particle after this one is 2.5 meters per second plus acceleration there is equal to 5, and the time taken for this collision is 4.4 seconds. 0.4 seconds. So this is going to be equivalent to velocity of A before collision is equal to, after the second impact, it is equal to 4.7 meters per second. And velocity of P will be now equal to, it is initial speed there is equal to, because it is moving in the opposite direction, so its velocity will be equal to minus zero point 0.5 plus time will be equal to 0.44 minus 0.4 into acceleration A there, that is equal to 5. So that thing is equal to 0.03 meters per second. Now they are going to collapse with respect to each other, and now we are going to find out the combined speed of that particle there. So before collision, the speed of the particle A is 4.7 meters per second, and speed of this particle B is there 0.3 meters per second. And now we are going to combine their masses. So momentum before collision is equal to momentum after collision. So before collision, the mass of this particle A there is 0.4 into the speed of that particle is 4.7 plus mass of this particle B there is 0.2 into the speed of that particle is minus 0.3 is equal to combined masses 0.4 plus 0.2 into the speed of that particle is equal to V. So we will get the calculation of V there is equal to, when they are combined, equal to 3.03 meters per second. So this is the whole question there, that B is going to first strike the barrier, then its speed is reduced, and then it is going to again collide with the particle A, and then you are going to calculate the velocity of A and the velocity of B at that point, and then you are going to use this law of conservation of momentum, and you can find out the final speed of this particle there. Now question number 7. Now question number 7. A particle moves in a straight line through the point O. The displacement of the particle from O at the t seconds is given by s is equal to t square minus 3t plus 2 with the t from 0 to 6, and s is equal to 24 over t minus t square over 4 plus 25 when t is greater than or equal to 6. Part A. Find the value of t when the particle is instantaneously at rest to the at the during the first 6 seconds of the motion wave. So, question number 7. S is equal to t square minus 3t plus 2 when t lies between 0 to 6 seconds. And s is going to lie between 24 over t minus t square over 4 plus 25 when t is greater than or equal to 6 seconds. And you are finding when it is at rest the value of t. Since the value of t is going to be calculated when t is equal to 6 and up till 6 seconds, the equation of the question there is s is equal to t square minus 3t plus 2. So s is equal to t square minus 3t plus 2. It is at rest. Rest means what? Velocity is equal to 0. Velocity means what? ds by dt. That is equal to 2t minus 3. That thing is equal to 0. So t value is equal to 3 over 2. That is equal to 1.5 seconds for this motion. So up till 6 seconds, t is equal to 1.5 seconds when the particle is at rest there. At t is equal to 6, the particle hits a barrier at a point P and rebounds. Find the velocity at which the particle is at P, arrives at P, and also the velocity at which the particle leaves the part P there. So it hits the barrier there. That means, second part, it is at O, and at the point P, it is going to hit the barrier, and then it moves back from this barrier there. You know one thing that in this equation, s is equal to t square minus 3t plus 2, and s is equal to 24t minus t square over 4 plus 25 when t is greater than 6 there. So you will calculate both the velocities because we are going to calculate the velocities at the point P when it hits and when it leaves. So for this portion, velocity is equal to 2t minus 3. And for this, the velocity is equal to, since s is equal to 24t minus 1 minus t square over 4 plus 25. So v is equal to 24 into minus 1 t power minus 2 plus minus t square derivative is 2t over 4 plus 0. So their velocity is equal to minus 24 over t square minus 2t over 4, that is t over 2. That is for the second equation of motion, and this is for the first equation of motion. So it hits the barrier after 6 seconds. So after 6 seconds, the velocity is given there. V is equal to 2t minus 3. So V is equal to 2t minus 3. So that is 2 into 6 minus 3. And that thing is equal to 12 minus 3, 9 meters per second. When it is going to arrive, and when it is going to leave the particle P, then the velocity is given there. Minus 24 over 6 squared minus 6 over 2, that is equal to minus 24 over 36 minus 3, that is equal to minus 3.3 meters per second. This minus indicates that it is bouncing back from this particle P here. So that speed is equal to minus 3.3 meters per second. So it is going to leave that particle at P here. So this is the two situations where they have asked these questions for this portion here. And now they are asking the third part. Find the total distance traveled by the particle in the first 10 seconds of its motion. So it is in the first 10 seconds of its motion, we are going to calculate on the third part. So you have to check out that whenever the displacement function is given to us, then we should know that what is the velocity and where the velocity makes a turn there. Where is going to stop? Is it going to stop between 0 to 6 or it is continuously moving from 0 to 6? So you will put the velocity v and that thing is equal to 2t minus 3 and then you put it equal to 0. Then t value is equal to 1.5 seconds. It means at the point p it is going to cover a distance of x meter when the time is equal to 1.3. After 1.3, it is going to make this turn again towards the P there. And then we are going to calculate the total distance traveled in the first 10 seconds of its motion. So we can draw this figure like this. If it is at the point O, this is the point P there, which is already at a distance of, if you put t is equal to 0 in it, so it is equal to 0 minus 0 plus 2. So that thing is equal to 2 meter. And then from this point P, it is going to move in the forward direction. And then it is going to cover the time in 1.5 seconds there. So you will use this equation of motion when t is equal to 1.5 in this part 1 there. So S will be calculated is equal to 1.5 square minus 3 into 1.5 plus 2. So this will become 2.25 minus 4.5 plus 2. It should be 4.25 minus 4.5 and that value is equal to minus 0.25. So minus indicates means what? It is coming backward to that position there. So this distance is 0.25. So again, after 1.5 seconds, it will move in this direction. So first it will cover a distance again of 0.25 in the same time there. Then after 6 seconds, it is going to move in this direction there. So now we can use this equation of motion where it is equal to Ts is equal to t square minus 3t plus 2 at the point P. So S is equal to, when t is equal to 6, it should be equal to 6 square minus 3 to 6 plus 2. That is equal to 36 minus 18 plus 2. So that is equal to 20 meters. So it is from this point P, it is a distance of 20 meters from this portion there, when t is equal to 6. Then, after 6 till 10 seconds, it is going to move the third last distance there. So now you can use this equation of motion there. The second part, because it is after 6 seconds, the equation of motion is this 24 over t minus t square over 4 plus 25. So we can use this equation until t is equal to 6, sorry, 10 seconds, it will be equal to 24 over 10 minus 10 square over 4 plus 25. So that thing is equal to 2.4 minus 100 over 24, 25 plus 20. So that is equal to 2.4 meter here. So it is from this point, it is coming back to this distance 2.4 meter. So this distance is basically equal to, from this position, it is 20 minus 2.4. So the total distance traveled by that particle is equal to S is equal to 2. It is at the initial there 0.25 when the first term there, then it's going to back there 2.5. Then there is 20 meter for the distance of t is equal to 6, and then 20 minus 2.4. So this calculation is equal to S is equal to 41.1 meters. That is the distance of this particle, total distance traveled, because these are the displacements. We have to give the total distance. So 22 meter plus 0.25 plus 0.25 plus 20 plus 20 minus 2.4 is the total distance traveled by that particle. P there, starting from this equation of motion. S is equal to t square minus 3t plus 2 when t is less than or equal to 6, and s is equal to 24 over t minus t square over 4 plus 25 when t is greater than or equal to 6. So this was the last question of this exercise of this mock paper. So I hope you will understand each and every part of this.